Another one of my videos. This one is for Eureka Math, Gage, New York, Module 1, Lesson 9, Tables of Equivalent Ratios. In this one, we will learn how to create tables of equivalent ratios. In order to do this, you'll need to identify the starting ratio and then use that ratio to fill in the table by using addition or multiplication. We'll talk about how both these methods work to fill in the table. These are the problems we're going to do. Examples 1 and 2 on page 32 and 33, and then examples 1 and 2 on page 34 and 35. We'll also have another video of the problem set on page 36. And if you're in my class, we'll also do you doing IXL. Let's go ahead and look at this first problem here. First of all, I just want to define, this will be the definition of a ratio table, is an organized set of equivalent ratios in a table. That's really just for the test. We'll have that as our definition of what a ratio table is. So here's our first problem. To make paper mache, the art teacher mixes water and flour. To every 2 cups of water, she needs to mix in 3 cups of flour to make a paste. Find the equivalent ratios for the relationship of 2 cups of water to 3 cups of flour. Represent the equivalent ratios in a table below. So we're just going to make equivalent ratios here in a table. And if we were going to start, we could just start. So we know our ratio is 2 cups of water. So we always just start with our first one and 3 cups of flour. Now be careful, because sometimes they'll switch these around up here. Make sure you put them in the right spot. Cups of water is 2. Cups of flour is 3. Because sometimes they'll put them in different order than what's on the chart here. And if you switch them around, remember, order matters. So if you switch them around, it's going to be wrong. So make sure you put them in the right one. Cups of water and cups of flour. Okay, then we're going to create equivalent ratio here doing this. And if we think of this, remember how we created equivalent ratios by, if we take 2/3 and we multiply that by 2 over 2, like we've done before, just using the giant 1 idea, we end up with 4/6. And so that would be another equivalent ratio, is 4/6. But notice that's just the same as adding this ratio over again. It's the same as adding the ratio to itself. Now, if we do that same thing and we take 2/3 and times it by 3/3, we would get 6/9. And that's another equivalent ratio, is 6/9. But notice, 6/9 is just if we add 2 to 4 and 3 to 6, we would end up with 6/9. So there's an adding pattern on here. We can just add 3 and add 2 to the one above it. So we could just add 3 and add 2. So there's a pattern there that we could use to create an equivalent ratio. Let's go ahead and do our next one here. So we have 2 times 3. Let's go ahead and just 4/4. And that would give us 8/12, which would be here. And again, that's just adding 3 and adding 2. Now, instead of writing the giant 1 like this, one thing we can do in a table is we can just show what we're multiplying by going like this. We can just show that we're going to multiply by 5. So 2 times 5 is 10, and 3 times 5 is 15. But that still follows that same pattern of just adding 3 and adding 3. So those are the 2 patterns. Remember, it said that we'll do it by adding or multiplying. Here's my adding pattern. I'm just adding that ratio, the 2 and 3, to the next ratio to get the next one down. Multiplying is the giant 1 idea. So in a table, a lot of times we'll show it like this. We're multiplying by 5. 2 times 5 is 10. 3 times 5 is 15. And all these others are generated the same way. 3 times 4 is 12. 2 times 4 is 8. So there's our multiplying pattern, and here is our adding pattern. You're going to want to know both these patterns because the adding pattern is really nice if you want to fill in a table, but sometimes these patterns, sometimes there'll be a missing value in your table, and the multiplication pattern will come in nice. So let's go ahead and look at the next one. Okay. So Javier has a new job designing websites. He is paid at a rate of $700 for every 3 pages on the web content he builds. Create a ratio table to show the amount of money Javier has earned in the ratio of number of pages he has built. Javier is saving up to purchase a used car that costs $4,200. How many pages must Javier build before he can pay for the car? So this one actually has a question they want us to answer, and we're going to use our table to do that. So the key is we have 3 pages, and pages is here. So the 3 goes there, and he has a rate of, so he gets $700 for every 3 pages, so he'd have $700. Then we could just, this is when we can just use our adding, so that would be 3, 6, so we're just going to add by 9, we're just going to count by 3, 3, 6, 9, 12, 15. Notice these are all just multiples of 3, aren't they? It's just like our times tables. 18, 21, and 24. And then we can add 700, which would be, that would be 1400. And these are going to be multiples of 7. So that would be 21. This is, and if you look at this, just remember how we were timesing. This is 3 times 4, so this would be 7 times 4, so that's going to be 700 times 4, so it's going to be 2,800. So this one would be 3 times 5, or we can just add 700 to that, however we want to do it, whichever is easiest. I just know 7 times 5 would be, and then 7 times be 4,200 because it's 700 times 6. So this one would be 7 times 7 would be 49, and it's just the 2 zeros after it. And then this one would end up being, I'm just going to show this, this would be end up being timesing by 8, sorry, not 9, but 8. And 7 times 8 would end up being 56, wouldn't it? Okay, now our question asks, how many web pages would he need to build in order to pay for a car? And we can look right here. He wants the car for that. So he would have to build 18 pages because that's what correlates to the 4,200. So he'd have to build 18 pages in order to make that much money. So again, you can create your table by just adding or by multiplication, however you want to do it. You can create your table either way. So let's go ahead and go on to our next one here. Okay, spraying plants with the cornmeal juice is a natural way to prevent fungal growth on plants. It is made by soaking cornmeal in water using 2 cups of water. So there's one of our parts of the ratio. So we have 2 cups of cornmeal for every 9 gallons of water. Complete the ratio table to answer the question. So cornmeal we know is 2 cups. Now we don't put any units in here. We just put 2 cups of cornmeal. The units are up in our labels. Gallons of water is 9. So we can just go 2, 4, 6, 8, 10. And then we can go 9, 18. If we don't know, we can just add 9 again, which would be 27, 36, and I know just adding 9 is the same as adding 10, except for we can take one away, so it'd be 45. Now, how many cups of oatmeal or cornmeal cornmeal should be added for 45 gallons of water? So here's our 45 gallons of water, and that correlates to 10 cups, so this would be 10 cups. Okay, Paul only has 8 cups of cornmeal. How many gallons of water should be added to make as much cornmeal as possible? So we find 8 cups. Here's where the 8 cups is. So 8 cups correlates to 36. So he should add 36 gallons. Of water. Okay, what do we know about all these values here? That's the next thing we're saying. These are all, just like our definition says, these are all equivalent ratios. That's the one thing we know. All these would reduce down to 2 to 9. This one we would divide them both by 3. This one we would divide them both by 2. This one we divide them both by 4. This one we divide them both by 5, and they would all reduce down to 2 to 9. These are all equivalent ratios. And that's like we said, our definition of a ratio table is a table of equivalent ratios. Let's go ahead and look at our last one here, okay? James is setting up a fish tank. He is buying to breed the goldfish that typically grow up to be 12 inches long. It is recommended that there be 1 gallon of water for every inch of fish length in the tank. What is the recommended ratio of gallons of water per fully grown fish in the tank? Complete the ratio to help answer the following questions. Okay, so let's go ahead. Now this one's kind of an interesting one. Typically grows, so the fish are 12 inches long. We need 1 gallon of water for every inch of fish. But look at our chart here. It's number of fish and gallons of water. But they say every fish is going to be about 12 inches long. So they need 1 gallon for every inch. So if we have 1 fish, that means it would be 12 inches. So that means we would need 12 gallons of water. So that one you got to kind of pull the ratio out on in. You got to kind of figure out what the ratio is, because it's not just 1 to 1, because it's 12 inches for every, or 1 gallon for every inch, and the fish are going to be about 12 inches long. So every fish is going to need 12 gallons of water. So then we can just build our table. 1, 2, 3, 4, 5. And then this is going to just 12, 24, 36, 48, and 60. Okay, what size of tank in gallons is needed for James to have 5 fully grown goldfish? So if he wants 5 fully, that's associated right here. He needs to have 60 gallons. Okay, how many fully grown goldfish can go in a 40-gallon tank? So somebody has a 40-gallon tank. It's asking how many fully grown fish can go in there. And we look right here. There's no 40 here. We have a 48, and our closest one to it is 36. 4 fish require 48. So we would have to use this one right here. So the 40-gallon tank could only have 3 fish, because we couldn't go over, because that would be too many fish for it. Okay. Again, what can you say about these values? All of these would reduce down to 1 to 12. So if we divided this one by each of these by 2, we'd get 1 to 12. If we divided each of these by 3, we'd get 1 to 12. Divided each of these by 4, we'd get 1 to 12. And each of these by 5, we'd get 1 to 12. So these are all equal ratios. Okay, so that's what you're going to be doing. This is our introduction to tables. Good luck with these. You should be able to do the problem set now. There will be a video for the problem set, but try the problem set on your own before you use the video. Good luck. Have a good day. Bye.